Hi, my name is Jared Davis. I'm a 3D artist and compositor with Zoic Studios. I've been working in the industry since 1997 and in 2003 won an Emmy for work on Firefly. In today's program, we're going to be making this scene. We're going to learn how to light a scene using background radiosity in a textured environment using background footage. We're going to break the scene up into elements to be combined later in a compositing program where you can add the finishing touches for a photorealistic effect. Let's get started. So now we're going to go into our 3D application. In this case it's Lightwave, and we're going to break this scene up into the appropriate elements so we can recombine them in the compositing program. And there's a certain kind of methodology when you're working in a studio or even at home if you have a small render farm. I like to get the elements that are complex or take a long time to do off onto the stack first so they can be rendering while I'm working on the other things, or anything that's not lighting specific, so I can get that done in a generic way, get it on the stack, and then when I'm ready to work later on, I've got those things. And then I do the lighting passes last because they have the potential to change over time and generally take the least time of the render elements to do. So we'll start here with our master scene file. And what we have here is the footage of a field and the ship going to land in it. The ship's already been animated, and this has actually already been lit, but we'll go in here and take a look at what we're going to do first. Now the first thing is in compositing is our base layer, which will be a background radiosity pass. And background radiosity is something that's probably one of the best and least known about features of Lightwave. It's a radiosity pass that does not calculate interreflection within polygons. So it's basically just getting the information from the background of the scene. What it does for you though is it gives you wonderful soft shadows in and around geometry that looks extremely realistic. And using that as your base pass instead of having any ambient light in the scene, for instance, just kicks up the realism a ton. So we started using that and we've been extremely happy with it. So in Lightwave, we'll make the background radiosity background from our scene. Now the textured environment has many options. So we'll go into the textured environment and open it up. I set this to the y-axis, although I don't know if it actually does anything differently. Now what we'll use here is an actual image from the background. We're going to load that up. What we want to do is the textured environment is going to be a spherical environment, so we need to have an image that is roughly even between ground and sky so that we can get the proper play. And I've chosen this frame, one of the frames from the end, as being very even with the ground. So we'll get some casting from the ground, some casting from the sky, and the horizon line, which is an average of the trees in the area. So in your textured environment, you'll choose an image map, choose a spherical projection, and we'll choose that field background texture. So I'm going to turn off pixel blending and texture anti-aliasing. They're really not needed here. And set your texture axis to Y so that your sphere will be standing up properly in the background. So now that we've got the texture environment set, we can take a look at what we've got. So we'll go into our light properties and we'll disable the diffuseness spec of that light. We're not interested in that. And go up to the global illumination tab. And here we've got our radiosity panel. We'll enable radiosity. It defaults to Monte Carlo, but we don't need that. We just want backdrop only. And we'll go ahead and leave the intensity at 100% and the raise per evaluation. We can actually turn down one notch to 3:9 as we don't need the precision of a 4:12 calculation. And we'll set our render to go and hit F9. So here we can see our background radiosity has actually cast light from the image onto the object, and it's more blue and brighter here and more yellow and darker here. because it's actually getting it from the image. Then when we go to composite it, we've got a base lighting that's actually taken from the environment, so the color correction will be very simple. Now you can see in the back here is what the texture environment actually looks like. You can use this as a background. In certain circumstances you might want to do that. In this case we don't. So the trick to getting the background radiosity working properly is to go to our compositing tab, and we're actually going to load up a new image. That is a simple black image. In this case it's just a 50 by 50 black square. It could be 1 pixel really. It doesn't really matter. You just need to have a black image in the background to block us from seeing the textured environment. And when we render again, you can see we're actually getting still the color and lighting from the background, but now we've got a nice black background. The black background is important for the compositing program. Lightwave is going to export pre-multiplied images. That is, they do a mathematical combination with the black edges where the ship is anti-aliased and the alpha. The compositing program will then subtract that out. It has to have one color. It doesn't really matter what color it is, although black is generally accepted. It just has to have one color. If you have a background image in and the compositing program tries to subtract that color out, it's not going to be able to, because there's going to be many colors around the edges. So choose a color, generally black, and stick with it. So that image is ready to go to the stack. The background radiosity is going to give us the appropriate amount of light, and we're going to have a lot of latitude to play with that in the compositing program when we get it in there. So we set this off to render and move on to the next piece. The next step in the process is to make a plane to grab the shadow of the spaceship as it approaches the ground. And depending on the situation, you may or may not want to use the same key light that you're going to use to light the ship. In this case, we're not going to. I'm going to use an area light, as it gives a softer edge to the shadow than a distant light could. So we'll go back to our radiosity scene that we had. We'll start getting things ready. We've already turned off our key light here. Let's go ahead and turn off the radiosity. We're not going to need that. And we're going to add another light. And we're going to add an area light this time. And we can just call it light, the same as we did before. We're going to move our area light over to where we think it'll need to be. And everything that's important with the shadow is going to happen at the end of the scene, where the spaceship is closer to the ground. So when I'm using an area light, I generally like to look through the light, as you can see where you're pointing at. We'll turn around here. So the spaceship is going to be backlit. We're actually going to kind of do the same thing here and create a keyframe at 0. And now we'll take a look at this view, and we'll see how it is. That's going to match up pretty well to what I have envisioned for the key light. So let's make our shadow object. And I've already made an object here that I call shadow catcher. And all it is a 1 polygon plane that's fairly small. It doesn't need to be big. And we'll just scale that up until it encompasses a space big enough. And we'll see how this looks. Turn our grid size. So what we want to make sure of is that the fighter is in the light view for as long as we need it to be. In this case, it's kind of moving out, so I think our light isn't far enough back. So let's move this back some. Create a key at 0 again. And we'll see how it goes now. Now the fighter's in the frame for the most important parts. The shadow is going to kind of ramp on as it approaches the ground anyway, so we're not terribly interested in what the shadow is doing at the beginning of the shot. So we need to make sure that we do have the ground plane on screen for all what we want the shadow for, and we do. So that the shadow is going to cast out here, and we'll be able to catch it. So we'll bring up our surface editor here, and we'll select the shadow catcher plane. And it's just a default surface right now. What we actually want to do is turn this to pure black, so that when it renders, it'll just be a black color. And then we're going to go to the Advanced tab and set our alpha channel to be shadow density. Now when you do that, the alpha channel of the object is actually going to render out wherever shadows cast. So what we're going to end up with is just a black smear wherever the shadow ends up in the compositing program. So that's all we have to do. One important thing to note is to keep the diffuse at 100%. You might think that you wouldn't need any diffuse on this since you're only interested in a black object, but the diffuse is important to grab the shadow. Otherwise, there is no shadow for it to grab, and the whole thing is for naught. So, we'll leave the diffuse at 100%. We'll go ahead and save out this object, shadow catcher, and then let's do some test renders to find out how our shadow looks. So we'll go ahead and turn off anti-aliasing because we don't really need that for our test renders. And we'll just do an F9. And now it's just a black image, but if you look in the alpha channel, you can see the shadow is down there. But it doesn't really look appropriate for where it should be. I think we need to have it a little lower to match the perspective. So let's just move this down a little bit here and give it a test. I'll just round that off. We end up with, let's round that off to 950 millimeters and then create a keyframe at 0. I'll do another test. That's better. That's a more appropriate perspective for it, and we've got more shadow to show. But it's still a little hard-edged, even without anti-aliasing. You can see that the edge is a little hard, and area lights are masters at making edges not hard. So what we can see here is that the area light is really small, and that's what's causing the shadow to have a very hard edge. So we're going to increase the size of the area light. We'll make it pretty big. Give that a shot. Key at 0, and then do another test. Now one thing to note is that as you make an area light bigger, the edges will get softer, but your render times are going to go up and up. So that's something to keep in mind. You want to balance between how much softness on the edge you need versus how much time you're going to need to render. And keep in mind that since we're going to have this in a compositing program, you can also do some blur in there. So you don't need to go crazy with the soft edges here. So our render's done. We'll take a look at the alpha, and there we can see that the edges are much better, not so hard. Even without anti-aliasing, these edges are much better and softer. So I think we're good to go. Just want to do spot checks as we go backwards through the scene here, and make sure that the shadow looks good in all the appropriate places. So we still got some there. I'll back it up a little farther. Let's back it up to where it's coming on camera. There. And there it is. So we look like we're good to go there. Now we'll turn our anti-aliasing back up. I usually use enhanced medium for something like this, especially at a video res setting. Another thing to note is in the global illumination panel you have shading noise reduction. And shading noise reduction is great for doing radiosity renders, and it also smooths out on area lights. But it's important to note that shading noise reduction does not anti-alias when you're using a shadow density alpha. So it doesn't do any good to turn it on here, and you have to make sure that your anti-aliasing is good enough to smooth it out as much as you need it to do. So we've got this. We'll go ahead and turn our light up to 100%, and then we need to prep our scene for rendering, which really we just need to get rid of the ship in the scene because all we're interested in is the shadow plane. So now we'll just go over to the Object Properties panel here. We will select our fighter here, and we want to set it to Unseen by Camera. This is going to keep it from rendering the camera view, but it's still going to cast a shadow. We want to do that for all 3 pieces of the ship. So then we'll just save the scene, and it's ready to render. The next thing we're going to do is an exhaust pass for the ship. There's some exhaust vents on here, and we're going to do a little voxel element that we're actually going to use as a displacement and blur element in the compositing program. So let's start that now. I've actually made an emitter object already, and I made this from the vents on the ship, and now we'll bring that in and parent it to the fighter. Now if we zoom in here, we'll switch to wireframe mode so you can see what they are here. And these 4 polygons here are small, just single polygons. They're lined up with the vents, and we're actually going to be emitting the hypervoxel particles from there. So we'll switch back to our camera view and put it back on shaded solid. We'll go to the Dynamics tab, and we're going to add an emitter. We'll look at the properties for this emitter and take a look at what it actually does if we just scrub through now. It's laying down particles, but if you see in 3D here, they're just being laid down where they are. So that's not really appropriate for the engine nozzles. So what we need to do is make them kind of blast out of the bottom. We're going to give them a negative velocity in the motion tab to do that. So we'll just start with say negative 30 here and see what happens. Now the particles are starting to blast out more, but they're going quite a bit farther than we really need them to. So we can turn those down with time. So they're currently set to a lifetime of 60 frames, which is way longer than we need. So let's turn that down to about 10. And now we can see that the length of the particle stream is much more appropriate. And we'll go back, and we're going to make sure that this is set to object surface. Lightwave 8 is pretty smart about picking what it is that you want, and it detects that there are polygons there, so it's most likely set to object surface. That's right. You want to turn down the size effect. It's just a good habit to get into. The size effect is something in particle dynamics where if you size up your emitter, it can do one of many behaviors. It can add more polygons or add more particles, keep the amount of particles the same. I like to get in the habit of just setting that to no change every time because they can be a little unpredictable, and I don't need that. So we'll go back in here, and now they're moving properly down, but they're not really spreading out like we'd like them to. So there's a couple of ways you could do that. You can either do that through explosion or vibration. I find that vibration is a little more appropriate in this instance. It's actually just going to kind of randomly move the particles out as they come down, and that's what we want. So now the particles are moving right, but we need a lot more of them. So we're going to turn the birth rate up to 500 particles per second, and now we see that we don't have enough particles at the end. So I'm going to set this up to 10,000 particles, which is way more than we need. But particle effects, when you save the PFX file, is only going to keep the number that it actually used. So you can set this to whatever you want it to be without worrying that you're going to end up with too many particles. So now we've got our behavior pretty much like we want, except for one little thing that is also a good habit of getting turned off, which is parent motion. There's some times when you want parent motion, but generally speaking, parent motion should be set to 0. So it doesn't inherit any of the motion of the object that is parented to. So now we can take a look at our particles here, and they're looking pretty good. But at the beginning here, we don't have any particles. Well, unless they just turn on their engine, this spaceship's going to need to have its engines on before. So we're going to set our start frame to negative 30, so we'll have actually started emitting particles before 0, so they'll already be fully out before. So now we can see that these particles are behaving like we want to. But they are intersecting the ground. That's not something we want. We want them to go ahead and hit the ground and behave properly. So what we're going to do is we're going to add a collision object to keep them from intersecting the ground. So we're going to add a null object, and we'll call this the ground. And we're going to add collision emitter to this. And we're going to set it to a type of plane. So it's going to be an infinite plane that goes out all the way. and we want to set it to a radius of level of 0. On a collision object, if you have a sphere, then the radius is the radius of the sphere. If you have a plane, the level is how far above the object's pivot point that plane is. And we want it to be right at the pivot point, so we set that to 0. So now we should have our particles behaving properly, and they should be intersecting with the collision object when they hit the ground, and there they are. So we want our particles to bounce. We don't need them to go crazy or anything. We just want them to not sit there and pool on the ground. So we'll go to our collision object here. Go ahead and turn our collision up just a little bit, our bounce power on our collision object. We can just dial that in until we see our particles behaving like we want them to. So now when we go through, particles hit the ground and bounce up just a touch so they don't pool. And that's much better. So now we've got our particles moving and bouncing properly. We need to drop our collision plane down to match the shadow plane, which is about 950 millimeters below 0. So let's select this and go to the end here. And we'll make a keyframe at our current frame so we can watch as the particles drop. And about 950 millimeters down. So we've got it set. We'll go ahead and make a keyframe at 0 and delete the one we just made. And now our particles are properly aligned with the ground. So now we're going to go on to the voxel part of this, and the thing to keep in mind here is that we're going to be using this as a displacement map and a blur in combustion, so it's not terribly important what it looks like. The most important thing is to get the texture of the voxels properly. We're not going to be going for beauty or depth or anything like that, since we're just going to be using it as an element for displacement. So we'll bring up our voxel panel. We'll pick our emitter object, and we'll bring up Viper. Viper is a great tool to use when you're setting up voxels. So let's make this a little bit bigger so we can see it. We've got it on surface voxels right now. We actually want to change that over to voxel sprites, and we can see that our particles are going to behave like that. So we're going to set our size here. The particle size looks pretty decent. I just like to use a round number, so I'm going to change that to 700 millimeters there. I'm actually going to use a gradient over particle age to size those up. So we go into our texture, and we'll choose a gradient, and we'll select particle age. And we know our particles are only 10 frames long, so we can set our end to 10 frames. And we want to make our particles, we'll make them about 200% here at the end, so that they'll be 200% bigger as they die than they were when they were born. And we'll go ahead and pick a keyframe here in the middle, just drag that up a little bit so they get bigger a little faster than they normally would. Let's go back to a little closer here at the beginning, and we'll play through here, see how it goes. So now we've got our particles to a decent size. We actually want to stretch these a little bit in the direction they're traveling. So we'll turn our stretch direction to velocity, and that's they're mostly going to be stretched down, the y-axis along their axis. We're going to shorten them a little bit. That's a little too long. And we're going to set them to maintain volume so that as they stretch out, they get a little thinner as well, and that just tends to make a good motion. So now we can see our voxels over different sizes here over different times, and it's looking good. Pulling a little bit right there at the bottom, just like we want to. The heat's going to get trapped underneath the spaceship. So the next thing we're going to do is we're going to deal with the dissolve envelope. We're going to make sure that the particles dissolve on and dissolve off properly. So we're going to use the same particle age gradient type. We set the end to 10 as well. And right now it's full white. This is 100% dissolved, so you see nothing over here. So we're going to determine where they come in and where they start to go out. And we're going to set it about to a frame, and we're going to turn the dissolve to 0, so that now they start out completely dissolved, ramp up to 0% dissolved. And then they're also going to be 0% dissolved at the end before they die. So they'll come on for a frame, live for 5 more, and then they'll take 3 to die. And that gives us a nice in and out point. The next thing we want to deal with is the texture of it. So we'll go over here to hypertexture, and I like to use a turbulence texture. It's just kind of a good generic texture to use. And we're going to use a velocity translate texture effect. And what this is going to do, as the voxel moves through, the texture is actually going to animate through it, and it's going to give a nice ripply kind of proper smoke motion effect. Texture amplitude starts at 50% by default. Usually not enough for something like this, so I'm going to turn that up to 150%. Let's turn off draft mode so we can get a better look. That's starting to get a nice texture in there like that. That's more like what we're looking for. Now, the next thing that we want to deal with is these areas in here where you can see it's clipping off, it's becoming pure white. And that does us no good as a in the compositing program because there's no data there, it's just pure white. So we're going to turn our luminosity down a little bit until that, yeah, that's pretty good there. So now you can see we've eliminated the clipping part. That means there's a nice gradient all the way from full white to full dark all the way through. And then the compositing program can use that entire range of values to do our displacement and blur effects. Even in the places where it pulls up, it's not completely clipping. It's stronger, but it's not completely clipping. And that's what we want. Let's just ram this off. Okay, now what we want to do here is, I know that the particles are actually going to be half in and half out of the ground here. And what I want to do is I want to go ahead and adjust our bounce just a little bit so that I make sure that the voxels are being used to their full extent. So I'm going to turn Show Particles on, and you're actually going to be able to see then OpenGL representations of the voxels out there. If we look at the side view here, we can zoom in and see that the particles are, there's all this wasted voxel below the ground plane here. So we're going to go back to our ground plane and so now we're going to dial our ground plane. This is where the ground is that we know from the shadow catcher. We're going to dial this up a little bit until the voxels are a bit above that. And then we'll be good to go. Now, the next step to follow before you send this off to your render farm or just set it off to render is you must save the particle effects file. The PFX file contains all the particle age and location information for all the particles in the scene. It's essential to do that if you're going to render over more than one machine. Otherwise, it'll calculate individually, and you can get variances in the calculations that cause you to have flashing frames. By saving a PFX file, you make sure that all the engines are looking at the same data, and they'll get you a proper sequence. So, it's very simple. We just click Save Motion, pick a place to save it. I usually have a PFX directory, and save. Done. Now, you'll notice that all the values here have been grayed out because they're no longer being used. They're just reading from a file. You also notice you've got little options here for playback speed. You can actually, when you're playing back a particle effects file, you can actually adjust the speed from the file. We're just using it to store information here, so we don't need to do that. Now this is ready to go off to the render farm. One other note about the voxel render is I only set my voxels to enhance low anti-aliasing with motion blur when I render it out. It's not going to be used for a beauty pass, but it is necessary to get some motion blur in there, otherwise the frames are just too crisp and clear. So you want to use a little enhanced low, but you don't need to go crazy with enhanced high anti-aliasing or anything like that. So the next step is we're going to do a voxel dust pass for the dust that gets kicked up by the engines as the ship comes into land, and found a clever little technique using an emitter object that I think you'll find very useful. So we'll go back to our scene. We'll add this dust emitter object. And let's take a look at just what this is. It's deceptively simple. It's just a disk. But when you use it with particles, it can be a wonderful thing. So we'll go to our dust emitter, and we're going to add an emitter. And it's going to default to object surface like it had with the exhaust, but we don't want that. We actually want it to emit from the vertices. And the reason we want to do that is because when you have an object and you set it to emit from the vertices, it's going to emit from the normals of those vertices. On a disk like we've got, the normals go straight out in all directions. This is going to give a radial output of particles that's going to be exactly what we want to see for dust being kicked up. So we'll take a look at our emitter here and see how it does its thing. And as we see, it's emitting particles, but they're not going anywhere. So we want to fix that. We'll go ahead and turn up their explosion some, and let's turn it up quite high. We'll see how they go. Now you can see they're emitting in a spiral pattern, and that's because we have fixed random turned on. When you have fixed random turned on, when you're using an emitter object of any kind, it emits one particle from each point in the point order of the object. So we don't want that to be on, otherwise it's going to keep emitting in a circle like this. We turn fixed random off, and now it sprays in a random pattern. That's exactly what we want. So the next step is to get this to be underneath the spaceship as we like it. So what we want to do is actually use a modifier that acts like an expression. So we're going to add the channel follower modifier to the dust emitter positions. We're going to start with X, and we're going to let it follow the fuselage of the starfighter. It's going to follow its X position. And then we'll also go to the Z channel, add the same thing, and follow the Z of the fuselage. So now if we take a look at the top view here, let it update, the emitter is actually following underneath the spaceship. Look from the camera view here, we can see that it's tracking underneath it, but staying on the ground level, which is exactly what we want. From the 3/4 view, you can see that it's emitting properly and staying right underneath it. And we already know that we have to set the ground plane is below 0, so we need to turn that down. But a quirky little bit with the channel follower is it's going to use the keyframed positions as the 0 position for it, and it'll offset from that. So we want to make sure that our 0 position is set for all 3 channels at once. So X is going to be 0 because it's going to be centered right under the fuselage. We're going to set this down to 950 millimeters as we did before, and Z is also going to be 0. We'll set that keyframe, and then when it updates, it'll be running properly. So now we've got it moving as we want, and we just need to get the particles behaving like we want. Now the part of this little trick is to keep a constant flow of very fast moving particles going through. So we're going to go to our motion tab, and we're going to turn our explosion way up. Let's try 200. Let's see if we get the appropriate spread from that. And that's looking pretty good. Yeah, that's looking good. So the next thing we need to do is make the particles come up. To do that, we're going to use gravity. And Lightwave's gravity defaults, it follows the exact same wide positive and negative, so we're going to make this a positive gravity so that it goes up. And we'll just try this and see how it looks. So now, that's what we want. This bowl-shaped kind of dust that comes up. Still a little regular though, because it's just coming out of the points which are not random, they're regimented. So we'll go back to our particles and we'll give it a vibration, and that gives us the randomness that we want. So now we've got these things moving really well. they're moving really high, which we don't need, so we're going to turn their lifetime down just like we did on the others. And cut that in half and see how that looks. So now the particles are going just exactly how high we want. So we want to turn the density up, so we'll go back to our emitter and turn the birth rate up to 300%, or 300 particles per second. And again, we've got the problem with the particles ending, so we'll make sure we've got plenty for the emitter. Now we've got our particles behaving in a nice little cloud, very violent and dusty. So we have the same problem we had before with the particles not being there in the beginning, so we'll go ahead and do the same thing and turn our fixed frame back to -50, so we make sure we have plenty of particles in the beginning. And there we go. The next step is to go ahead and take these into the hypervoxels. So go ahead and add voxels. And turn on our dust emitter. And turn on Viper. We've got surface particles again. We'll change those over to sprites like we did before. So this is a pretty decent particle size here. We'll just go ahead and round this off because I just love to work with round numbers. And we're going to go ahead and set this to a particle age gradient again. And we know that our particles have a 30 frame lifespan, so we'll work with that. And let's just set this up to say 250%. It's more important in this one because we're going to be using this for a beauty look that the particles look good. So we want, as the particles get farther apart, we want the hypervoxels to get bigger to fill in the gaps between them, so it makes a nice continuous space. So that looks like it's filling in all the gaps. Let's bring it a little closer here. Yeah, that's a nice space. It's looking good. So we'll go ahead and do another dissolve gradient. So we'll do the same thing, particle age gradient, 30 frames. Drag that down to 30. And now they're 100% dissolved. We'll pick a place where they can be 0% dissolved. Now in this case, I'm not going to set 2 keyframes here. I just want them to come to a peak of opacity and then immediately start dissolving off, and that'll give a nice kind of ramp on, ramp off to them. So they're going to ramp on over a little close to 4 frames, and then they'll ramp off over the next 30. Now what we do have to deal with here that we didn't have to deal with in the other voxels is the color. So let's go over to our shading tab and make ourselves a nice brown color. The grass is kind of a brown, so we'll go ahead and start turning that, dragging the saturation up here, and we'll drag the hue over towards yellow. So this is a little bright. We'll bring this down some. And that looks like a pretty good color there. It's clipping here as the other one was, so we're going to want to turn this down some, say 75% luminosity, and that's going to make sure that we don't get any of that nasty clipping. I'm going to turn the density down just a little bit too, just to make it a little less thick. And we'll have some control over this in the compositing program too, but it's we have to get this one a little closer to finished than we did with the others, since we're actually going to be seeing this on screen. Now we're going to go over and set our hypertexture. We're going to set that to turbulence, and again we'll turn this up to 150, so we get a nice texture there. And we'll go ahead and set this to a velocity translate, so it'll move properly. And then that's getting us pretty close. So now we're going to set a texture amplitude gradient here, and this is actually going to turn up or down the value of the hypertexture over our particle age. So over 30 frames, what we're going to do is actually just turn this down a little bit. As the particle gets older and gets bigger and more diffuse, there is just a little bit less texture as it goes along, and it just makes a little better, more realistic look to it. We just do a few checks here throughout, and up close here, and that looks pretty good. So let's go back to our particle emitter. Make sure to save the PFX file just as we did before. I'm going to save this as a dust emitter. And then we'll go and we'll turn our anti-aliasing off. Now, for this one, we want the ship in. So we need to make sure to turn off unseen by camera, but we're going to use these up here. What we're going to do is we're going to turn these into holdout objects. And a holdout object is just a black alpha object that is going to basically block the dust that's behind the ship and make that fit nicely in 3D when we put it in the compositing program. So we'll turn this to a matte object, which turns the color overall to black, and set our alpha channel to constant black. And I'm going to do this for all three pieces of the ship. Make sure unseen by camera is off on each one. Now for the shadow catcher, we don't need that at all. So we'll bring up the scene editor, and if you want to get rid of an object so that it doesn't behave in the scene at all, you can turn off this check mark here, and it's like it's not in the scene, period. So the shadow catcher is no longer an issue. So let's do a quick render. We'll back it up a little bit so that particles are a little smaller on the screen, but we've still got the ship inside there. And we'll do an F9. Okay, so this is our hypervoxel render, and I can see a couple of things here. First of all, we've left the area light from the shadow catching scene in there, and that's going to increase the render times on voxels a lot, and we don't really need it. We've also left shadow casting on here, which in this particular scene I don't think we need. There might be times when you'd want to have shadows cast through your voxels. Just keep in mind that's going to turn the render times up quite a bit as well. So let's go back and fix these things. The area light we can just get rid of. We'll delete it. Then we need to turn the diffuse back on for our original distant light. And then we'll turn shadows off, because we don't need them. And then we'll do another render. And that looks like what we want. So now we've got the particle effects file saved. Let's go ahead and turn anti-aliasing to enhance low. Make sure motion blur is on. And we can save this scene, and we're ready to move on to the next part. So now we're going to turn to lighting the scene. We're going to use a key light, and then we're going to break it up into the different elements, so we're going to recombine the compositing program. We're going to see what we can do with all the buffers that Lightwave has to offer. So we'll go back to our original scene. So now we've got our master scene loaded here, and we're going to move our light around to get it looking the way we want it. We've got our default Lightwave light here. We want to go ahead and move that up just to where I can see it. I like to move the light into vaguely the direction, the position that the light was coming from in the background plate. So we can move that there and rotate this around. See it on the OpenGL here. And we can see that it's pretty backlit from the plate. We've got a lot of shadow here, and the ridge, the crest of this hill has been lit here, so those give us some lighting cues that we want. We can also see the sky is brighter in this corner than this corner, so there's probably a little bit of light shining through the haze over here, so those are some of the things that you can look for. We'll go ahead and rotate this around, looking at the OpenGL until we like what we see. And that looks pretty good right about there. So let's make a keyframe at 0, and we'll do a check. Make sure our anti-aliasing's off, we don't need that. And do an F9. So that's looking pretty nice. It's getting nice little specular hits here and nice little diffuse. We don't have to worry about this dark stuff here because this is all going to be filled in by the radiosity pass that we did earlier. So we're only interested in getting the actual key light set up here. I want to make sure that our shadows are on and do another test just to make sure that everything's falling into place properly. And yeah, we can see that we've got some things we like here. This is looking pretty good. Now we want to make sure that the light is set to 100% and it's actually kind of a brighter scene, so we're going to turn that up a little bit to 150%. And I also want to make it a little bit yellow. It's going to be not too much, but you just want to give a little bit of color to your key light sometimes. Just gives it a little more character. Let's take a little render here. Alright, that's looking even better. We're getting some more light. It's starting to get more like at the level of contrast between bright and dark that we're seeing over here. The angle's good and the color's good. So now we're going to break it up into elements. We're going to use some of Lightwave's export buffers to do that. We're going to break it up into diffuse pass, a specular pass, and a reflection pass. And also a little more data that Lightwave has to offer. So we want to go over to our image filter panel. And we're going to take a look at the buffers that Lightwave has to offer. And in order to do that, we're going to add the Render Buffer View plugin. We double-click this. These are all the buffers that Lightwave uses to calculate its final renders. And we can turn all these on and see an output from each of them. So what we're interested in right now is diffuse shading, specular shading, raw RGB. And we'll do an F9 to see what these have to offer. You'll want to use the image viewer that comes with Lightwave to do this. This will show the final rendered image and the buffers as accessible layers that you can look at. So here in the image viewer, we've got our final render. Then over on the layer tab, we can look at these things. Diffuse shading is going to show you just the diffuse result of the light. And then specular shading is just going to show you the specular highlights. And the raw RGB is going to show you the color of the textures regardless of light. So we're going to use these three to combine these in the compositing program to reconstruct this original image. But in breaking it down into elements, we'll be able to adjust each of these individually. So buffer view has shown us that what our results are, but in order to get them out, we need the render buffer export. And it's going to give us all the same buffers that we had access to in the render buffer view, but now we'll be able to actually export them to files. So we're going to choose the diffuse shading buffer, and that's different from the diffuse buffer. The diffuse shading buffer is going to give you the results after the render of what is diffuse in the scene, whereas the diffuse buffer is going to give you a render of the diffuse values of the textures throughout. So we're only interested in what's done after the render, and that's what we want to use. So we'll select diffuse shading, and there's three options. You can either export it to an image file, you can have it export over the rendered RGB, or you can export it to the rendered alpha. We want it to go to an image file, so we're going to go ahead and choose Targa 32 and give it a file name. Now I like to have a renders directory, make a place for the fighter, and we'll break it up into different directories. We're going to call this just diff. This will be the diffuse pass. We'll call this fighter diff. One little quirk with Lightwave, maybe it'll be fixed someday. It's going to append a period to the end of your file. You have to delete that manually. Don't forget to do that, or you'll get things with underscores and periods. So now, whenever we do a render, this is going to export the diffuse buffer to that file. Now this is extremely important. This will write out to a file even if you do an F9. This can kill you if you reload a scene to do tweaks on it later and you start doing F9s on it. It's going to overwrite the frames that you already did. So it's very important when you start using these image filter plugins that you go in and uncheck them turn them off before you start doing test renders again. I have destroyed so many files this way. Don't let it happen to you. So, we've got the diffuse taken care of. We also want to export the raw RGB. So we're going to export, set a render buffer export again, and we're going to turn this to the raw RGB, target 32, and we'll give it a raw RGB directory. Call it fighter raw RGB. Get rid of the period, and then we're good to go. Now, between the two of these, as you'll see when we get to the compositing section, the raw RGB is going to give us the color of the fighter, and the diffuse is going to give us the brightness of them. We'll combine this together to create the rendered diffuse pass as you would see in Lightwave. Now, before we set this off to render, we want to turn the specularity off on the light, so we're not interested in that right now, so we don't need that. Now that we've got the diffuse and raw RGB buffers set up, we need to make sure that we turn the background image back to black before we render it. Then we can move on to the spec pass. So we set this back to the black image. Make sure our anti-aliasing is good. We'll go over to the render options panel, and we're going to set this to export as well. I'm going to store this into a diffuse pass directory. Lightwave is going to render this anyway, and even though we probably won't end up using this in the scene, what this is going to do is this is going to give us reference of what the actual diffuse pass looked like in Lightwave, so that we can make sure, just do a reality check when we get into compositing to make sure that what we're doing by recombining the elements is looking like it was in Lightwave. Now we've got this done, we can save the scene as a diffuse pass. And now we'll move on to our specular pass. Let's go to the light properties, and we'll go ahead and turn off diffuse and turn on spec, and we'll go over to our render buffer export panel again. And since we're only going to be exporting the specular buffer, we don't need this second one, and we can go up here and set it to specular shading. Now, specular shading carries the same caveat as diffuse shading. Specular shading is the result of the render. Specular by itself is the specular value of every texture on there. So make sure you get the specular shading. That's what we want. We'll go ahead and make a spec directory for this. And delete the trailing period. Our anti-aliasing is already set, so we can go to our render options panel, make a spec pass directory. Same thing here, just a reality check. And we'll save our scene. And we're good to go. So now that we've got the specular diffuse taken care of, we're going to move on to the reflection pass. Up until now, we've been using an object that has no reflection on it at all. We didn't want that interfering with the diffuse or specular colors. And now that we've gotten those taken care of, we're going to do a reflection-only pass. Take all the lights out and just get the reflection. In order to do that, I've made a separate object that has all the reflection applied. And let's replace that now. We'll swap out this with a reflective object. And just to show you what's going on, just pick a surface here and look at the reflection texture. And this is using an incidence angle, which gives the nice Fresnel effect, it's called, where the object gets more reflective as it becomes more edge on to you. So now we'll open our render buffer export. We're actually going to remove this, as we're just going to be going right out of the camera with this one. Turn our anti-aliasing off and turn our lights off and do a quick test render. So there you can see that we've got no lights in the scene, just a reflection, and the reflection is actually using the same texture and environment that the background radiosity did. So we're getting the reflection of the sky here and the ground here. It's not physically accurate, but since the ground that it's on is so generic, it's perfectly fine. Will look great and no one will ever know. So we go over to the camera, set our anti-aliasing back. We're going to go to the render options panel and we'll give it a reflective directory. And then we can save this scene. Now that we've got all the elements done, we're going to bring them into combustion and put them all back together. So, we've got combustion up here, and we're going to open our files again. We'll start with the background, and we'll bring this in. Now there's a quirk with combustion where it has presets. It's going to detect the size of your footage and it's going to set the frame rate according to that. That means it's going to bring in our video sized files at 29.97. We want to work at 24. So there's a couple of ways to deal with that. You can either change the FPS setting on every element that you bring in, or you can bring in one element, set the FPS properly, and then do an import into that workspace. That's the way I prefer to work. So I set it once, and then I start importing files, and they all get set properly. So we're going to start with our field background here, and that's going to pop it down here, and we want to click on this and go to sequence options and set the frame rate to 24 FPS. Say OK to that, OK here. Then we want to go ahead and let it automatically make a composite, a 2D composite with our footage in it. Now we've got our footage in, it's at 24 FPS. Now we'll want to file import footage, and then we can bring in the rest of the renders, and no matter what it automatically defaults to, it will set them to 24 FPS since that's what our workspace is. So we can start bringing in all the elements here. Combustion lists files according to a sequence if you have collapse set. You can uncheck collapse and you can see all the individual files here, but with collapse on, it will show you that this is an actual sequence and it'll treat it as one item. So we'll go ahead and bring in our diffuse pass, dust pass, exhaust pass. Just clicking once is what's going to bring these into this list over here to be imported. Now we've got this big list. We say OK. Now everything's in. It's not in any particular order though. We need to go ahead and set that up. We're going to go ahead and turn these layers off so I can just start dealing with the layers that I want to look at one at a time. Start with the background radiosity layer. Let's advance to the end here, and we can see that we've got the colors from the sky and the colors from the ground. It looks good. This would be what it would look like, you know, if you turned off all the lights except for an ambient light. But since it's radiosity, we've got all these great little details where there's geometry that makes it tight, and the shadows look really good. We'll turn that off, and let's deal with the next one. So we'll go ahead and turn on the raw RGB pass. This is the raw RGB from the texture with no lighting applied to it. We'll go ahead and turn on the diffuse element that we rendered. Here we can see it's just the diffuse lighting. And we're going to turn this into, change the layer mode to multiply mode. And you can see that's going to darken it down quite a bit. And what multiply mode does is basically does a multiply for the colors for each pixel. So if you multiply by black, you'd get 0 because black is 0. And what it does here is it takes all the dark spots and puts them down to dark and leaves all the white ones alone with the color from the raw RGB. Now what we should see here is that the fighter diff plus the raw RGB should be about equivalent to the diffuse pass that we had rendered in the same render scene. And if we look at those, it's about the same. The benefit is that we now have these as separate layers so we can tweak them to our heart's content. So we've got those good. Let's check out the rest of them. We've got the dust pass. Dust pass looks good. You can see the cutout of the ship here, where the holdout object actually cut a hole in the alpha. You can see here's where some dust went in front of the camera, in front of the ship, and here's places where the dust is behind. You can see that edge. So we'll look at the exhaust pass, and here's what we can take a look at what happens when you don't have the alpha set properly. By default, sometimes combustion will bring something in, even though it's pre-multiplied, it doesn't turn pre-multiplied on. You can see what happens is you get these dark ridges around here. That's because it's not subtracting out the black again. We turn pre-multiplied with black on. There you can see the edges pop out properly, and that's how we should see it. We want to check this on everything, make sure our dust pass is doing the same thing. It should also be pre-multiplied. That looks better. No more black edges. Raw RGB, also want pre-multiplied. Take a look at the reflection pass here. We can see that it's reflecting the sky and the ground properly. We'll check that it's pre-multiplied, good. And then our shadow pass. And our shadow pass ends up looking something like this. You can see it kind of move across the landscape here. You notice that combustion dereses when you have this feedback turned on. It will automatically derez in order to keep up with you as much as possible, and it'll degrade further the faster you go until it can keep up. If you don't want that to happen, you can uncheck feedback, and then your frame response will be slower, but your frames will always be full quality. So we'll check out the fighter spec pass as well. We'll set the raw RGB underneath, and we'll select the fighter spec, set that to hard light. And we're getting the color from the object now, and the spec highlights from the spec pass. And if we look at our spec pass just for the reality check, they're nearly identical. So now we've got that back, and all the tweakability that comes with having them separated out. So now we can blow away our spec pass and our diffuse pass. We don't really need them, and they'll just confuse us. So now it's always a good time to go ahead and save the scene. Save that here. I like to make a CWS directory or a combustion directory. And we'll just say fighter setup 1. And now we can continue. Now since we're going to need the raw RGB for both the spec and the diffuse, we'll go ahead and duplicate that layer. Now we have one for each, and they're in properly. And let's go about the process of layering all these things together. We're going to start with the background radiosity pass. That's going to be the base pass, and we'll go ahead and turn the fighter diffuse on. Now what we want to do is these two are now really going to act as a unit. So we want to be able to tweak them as a unit without having to tweak 2 layers at a time. So we'll go up to Object, Nesting. We're going to nest the selected layers as diffuse. Now we can see we've still got both layers here now under a new composite, and then we can do all of our operations on this one layer unless we need to tweak the other 2 layers beneath it. We want to do the same thing for the fighter spec. We'll select these and we'll nest. And now they're nested. So how do we apply these so that we can put them on? We're going to use a layer mode called Screen. Screen is similar to Add, which just basically adds the pixels to the top. Screen actually adds pixels on the top, but instead of going towards the ultimate white, it heads it towards the color's original layer. You can find better descriptions on the internet, but that's basically what it is, and we're going to screen the diffuse and the spec on top of the background radiosity layers in order to bring the highlights up. So we'll go here to our layer transfer mode, and select screen mode, now we can see it's laid over all the highlights with the color of the diffuse pass on there onto the top of the RGB pass, onto the top of the background radiosity pass. So we're starting to shape up into something here. The next thing would be to put the spec pass on, and we're going to do the same kind of thing for that. We're going to turn it on and turn to screen mode. So now that we've got the diffuse and spec passes turned on here, we're seeing a little edging around the object here. And what's happening is inside the nested comps here, we've got this footage that's got pre-multiplied alphas turned on. And basically it's brightening the edges, and then the screen mode is brightening the edges again. So we're getting a double whammy around this edge here. So what we need to actually do is go back into these nested comps and turn the alphas off just on the diffuse and spec passes themselves. And now we've taken care of the edging problem, and it doesn't affect the overall image at all. So we've got those properly combined. Now we can start layering in the other elements, the dust and shadow and reflection. I'm going to start with the reflection pass. It's going to go on top, and it's also going to get screened on. As you can see, without the reflection pass and with the reflection pass adds a lot of detail to it. And we're going to get into tweaking that in a little bit. But first, let's deal with the shadow pass. Shadow pass comes on, and you can see that it's there. We'll go ahead and pre-multiply that so we make sure that we do get the brighter edges around here. And then we'll go to the end where we have the ship at its closest position. And you can see that the shadow's dark, and it's, you know, probably a little too dark for the dark parts of our scene. And we want to take a look at the other parts in the scene and try and match to that a little bit. So we've got some trees back here that are, you know, clipping to black, so they're obviously very dark, but they're not black. And they are farther away, so they're not going to be as black just because of atmospheric haze, but the shadow is still a little bit black here. So basically what we'll do is we're just going to turn the opacity down on it a little bit until we like it. That's a little too light, so... And that's looking about good. Now, we softened the edges up some by using an area light earlier, but we want to do a little bit more of that. So let's go ahead into the operators here, and we're going to go to Blur, Sharpen. We're going to add a Gaussian blur, and then we'll pull up the Gaussian blur controls here. And we're just going to dial this in until we get just a little bit of softening around there, a little too much there. So just a little something to make it look a little less hard-edged and CG. That looks pretty good there. Go ahead and save the scene. Always a good idea to keep saving. Now we've got our fighter laid in there nicely with the shadow. And now we can start dealing with the exhaust and dust passes. And I'm kind of taking these back to front or bottom to top really, because once the dust and the distortion passes are laid over the shadow, you're not going to see the shadow as much. So you want to take care of that as if you didn't have any dust or exhaust pass, get the shadow looking good, then you can put the stuff on top of it. Likewise, the dust pass is going to go on top of the distort pass, so we want to take care of the distortion first. Now, we'll take a look at the exhaust pass here, and we can see how it looks. Something like this. The voxels coming out. We've already taken care of the pre-multiplication on that, so that's no problem. But like I said earlier, we're not actually going to be using this as a smoke pass. We're going to be using it as a distort. So what we want to do is we want to turn that off and go down to our background, the field background here. And we're going to apply a distort operator called displace. Now when we apply the displace, we get these controls. It's going to ask us for a layer to point to. This is what it's going to get the displacement information from. Then it's going to be able to grab from any of these channels from that layer. So we'll go ahead and select the exhaust pass as a layer. And it's pulling from the red channel. You can already see how it worked up a little bit. See the before and the after. And we're going to go ahead and leave it on, actually let's turn it over to the luminance channel. So we just rendered black and white images. The luminance has the most data there. We can see how it's starting to warp things up here. But I actually kind of want it to warp down. So we're going to dial that down until it's pushing down. That might be a little harsh there. So we'll take a look at how that looks. So now we're going to back up here and we're going to make a quick preview, and it's just going to go through and render these things. We've set in and out points, so we're only looking at a selected portion of it. And you can see here that the distortion, the displacement map is actually going to push all the pixels on the layer that we've applied it to in the direction that you specified according to how bright the image is underneath. So that exhaust we had, where it's wider it's going to push more, and where it's blacker it's going to push less. So now we can see that we've got a nice little heat ripple going on underneath there, and it's looking very much like what you might see behind a jet engine at an airport or an air show. And like that very much. The attention we paid to the movement of the hypervoxels really paid off, and you get that nice ripple going on there. Now that's only part of it. Another part of what we want to do to distort the image is to actually blur it. If you'll think back to when you've seen out the back of a jet engine, it also does a bit of a blur there. So we'll go back to our operators, and we're going to add a compound blur. Now, compound blur is basically the same kind of blur as any other that you would apply, but it allows you to select a layer to define what gets blurred and what doesn't, much the same way the displacement does. So we're going to pick the same exhaust pass, and we're going to pick the luminance channel, which is selected by default. We'll choose a Gaussian blur type. Let's zoom in here so we can see the results. We'll start with the 3-pixel blur. And now you can see that underneath there, it's getting quite blurry. Maybe a little too much. We don't want to destroy the whole scene, but let's change it down to 2 and make another quick preview. So now we can see that the blur is looking very nice there. You can really look like it's putting some power out from those vents. Now, if you wanted to, something you might want to do on occasion, just depends on the context of the situation. You can also take the exhaust pass and put it back on, and then we'll apply a color corrector operator. Just do a quick color correction to turn the brightness all the way down. Basically make it black smoke. And then what we'll do is we'll turn the opacity way down, say maybe 20%. Just so it's got a little bit of smoke underneath there. It would depend on, what was necessarily called for in the scene. If you have a really clean kind of ship and you don't want to have that, like a Harrier, you don't really see much smoke coming out of those. But if you had some sort of a junkier ship or an old ship, or you could even do a certain amount of color with this, although since we didn't pay attention to the color and hypervoxels, you probably want to do a separate pass for that. But this can get you a little ways, and it can just darken it down and combine with the blur and the distortion to look pretty cool. So yeah, that looks good. We're liking that. So I don't want that exhaust pass in this scene. I like it better clean. So we'll turn that back off, and we'll start looking at the dust pass. Let's just turn it on, see how it looks in its raw form. Pretty good, but seeing this range of colors here, this dust is just a bit more yellow, and this is just a bit more pink. So let's go ahead and add a color corrector here. Now, just a note on color correctors here. Combustion has an amazingly powerful color corrector. It's very similar to the ones on hundreds of thousands of dollars flame and inferno systems. It's got a really great suite all-in-one operator, and it also has these same things broken out into other ones. Programs like After Effects have separate color correction tools. After Effects has an equivalent to Combustion's histogram called levels, and there are also brightness and contrast controls, hue, tint, saturation, these all controls. What I'm trying to say is that Combustion has all these in one operator. After Effects has them all split out in all the operators, but there's nothing that I'm doing here that couldn't be done in any compositing program. You just have to find the appropriate tool. It's going to be in there, it just might have a different name. Now inside here, we've got the histogram, which is the equivalent to After Effects levels, as I mentioned. And this is my favorite tool to use because it gives me a visual representation. What you're seeing here on this panel is a representation from darkest to lightest of how many pixels exist in those scenes. So we can see that this peak here is the brightness level of where most everything shows up. Over here you can see we've got controls for RGB and then red, green, and blue. This shows you the same histograms for each channel individually. So you can see that there's a combination of all the colors in there. You can see a peak for each one. Now we've got master, shadows, midtones, and highlights. Master controls the overall color correction for the entire color range. And shadows, midtones, and highlights will give you a separate set of controls for each one of these color ranges. Now, the ranges tool is an amazingly powerful tool if you know how to use it, and it took me a while to get to know how to use it, but it's really simple. The ranges tool allows you to define what the shadows, midtones, and highlights are. You see over here we've got an S, and this slider, and this Bezier control. These things are what define the shadow. Anything to the left of this S is considered a shadow color, and you can see that the shadow also has a curve, so things approaching the S are becoming more and more influenced by shadow. Same here as highlights. Anything to the right of this is a highlight, and there's also a curve as it approaches. Then anything that falls in this range is the midtone. So it's all a curve. There's no division that's hard. It's a very fluid kind of thing. It's wonderful to be able to define the ranges of shadows, midtones, and highlights yourself. We're not really going to need them in this case because we've got a fairly narrow range anyway. But if you need those kinds of things, they're there, and they're extremely powerful. Let's go back to the histogram here, and since we know that this is a little more pink than we want, and this is more yellow, which is what we want to go to, there's a few ways you can do this. This is one of those no right or wrong answer to it. The two schools of thought are basically you can add more of the color that you want, or you can subtract the opposite of the color that you don't want. Obviously, one of them is going to be more appropriate in every situation. Subtracting a color tends to make things darker overall, and adding tends to brighten things up here. I think this is plenty bright, so I don't mind doing a little subtraction from there. So what we want to take out is some of the red. If we remove a little of the red, that's going to bring the green more up because they're opposites. So we go down here. The histogram tool shows you your input points and gamma and your output points. And what each of these mean is basically this is your black input point, and anything to the left of that is going to be pure black. Anything to the right of this is going to be pure white. Now obviously, since they're at the full left and full right, there's nothing brighter or darker than them. But you can slide them so that now we've defined anything back here as being pure black. Anything over here as being pure white, so we can brighten things up tremendously. Down here are the output points. This is the darkest color that will appear on the screen. Right now it's set to 0, so it can go all the way to black. If we turn that up, then the darkest color that could possibly be in this element is 78 value. And likewise, over here is the brightest color on the screen, which is 255. If we turn that down, the brightest anything could possibly be is 171. Now, since you have controls for each of these channels, it's an easy way to subtract out some green. It's just to turn down the maximum green value that can appear. And then we can take some blue out, which is going to tend to go more yellow. It's a pretty subtle thing. That's starting to look better, more like what I'd intended. That's the great thing about compositing. It allows you to get so far in 3D, and then you can take it the rest of the way in comp and save a lot of time that way. Also noticing that our dust pass is under our shadow pass, which is a bad idea, so let's go ahead and take that on top. That's better. So now that we've got this good, we can play with the opacity a little bit. We can just turn down the overall opacity of the layer. It can be handy. Or we can also play with the alpha of it by going to keying alpha levels. The alpha levels is actually going to give us a histogram tool that instead of representing the color represents the alpha. So we have gamma controls for the alpha. We have the maximum and minimums just like histogram tool. So this is another way. By dropping this, for instance, would be about the same as dropping the opacity overall. Now all these tools are also animatable, and what we're actually going to do here is, since the ship starts off high, it's not going to be kicking much dust because it's not quite there yet. So as the ship comes in, we're going to animate the dust coming on, and we're going to do that just using the opacity. To do that, we'll go back to our composite controls and opacity, and we'll start back a little farther in the scene. Start to think about where it is that we want the dust to start kicking on. That looks like a fairly good location, actually, somewhere in the 30s here, maybe 40. So let's do this. We'll click on the animate button. The animate button turns on bright red to remind you that anything you do now and any value that's animatable is going to make a keyframe. So you want to keep that in mind. Turn that off whenever you're not using it. So we'll go to the opacity here and we'll turn it down to 0. And now it's completely off, and there's also been a keyframe made in our timeline for opacity. It's also made a keyframe at 0, and we're going to go ahead and delete that now because we don't need it, and it's just going to make our curve different. So we'll go ahead and go forward to where we want the dust to be full on. This looks like a good place for the dust to be completely on. So we'll go back and ramp that up. So now the dust will be all the way on there. And we can take a look in our timeline again. You can see we've got keyframes here and here for on and off. If we look at the graph mode, we can actually see the ramp going from 0 to 100. Now we'll take a quick look here in the middle of things. See it start to come on. We'll turn off animate because we're not going to use it anymore. We don't want it messing something up later. And let's do a quick preview at medium quality, which will get us there a lot faster than best quality and give us a really good representation of what we'll have. So we can see here that the dust is on, it's ramping on, it's looking pretty cool. It's a little heavy and probably needs to be a little bit darker, and we'll take care of that, but that's one of the things about compositing is it allows you to tweak until you like it. And I can make this until I like it, but you may not. So go ahead and tweak until you like it, and you've got lots of flexibility, lots of power with all these elements that are broken out. You can do anything you want to with them. We'll go ahead and continue on until I think it looks great, and then you should take it beyond that. So we'll go in here to our alpha levels, and we use the alpha level so we don't have to mess with the opacity again, and it'll do the same thing here. We'll take down the maximum a little bit so it doesn't get too heavy. Also going to bring down the gamma just a touch. It's going to kind of change the midpoint of the opacity, and that's going to be a little bit better, I think. And we'll go ahead and go into the color corrector, and let's bring the overall down a little bit. Make it a little bit darker. That seems to fit the scene better. Yeah, check through there like that. And that looks better. Now that we've done an initial pass on the exhaust and the dust, there's a couple little things we need to take care of. First of all, because the exhaust goes in front of the ship so much here, we're going to want the exhaust to distort the ship as well as the background. So what we'll do is very simply, we'll take the two operators, the compound blur and the displace that we have here, we'll select them both, and we'll copy. Then we'll take our background radiosity pass here and paste them. And those same distortions will get applied to the background radiosity passive there. Since most of our diffuse and spec hits are happening on top, I'm not too worried about distorting them. The background radiosity pass is the one that's actually going to take the brunt of it. We actually might want to go ahead and copy those onto the reflection pass as well. Just paste those again. It's going to show up as well. Then we'll have those nice and distorted. You can see that blur coming in around there. And it looks really nice. Starting to blur up the ship. So now that we've got those things coming together, we can start to tweak on the individual layers of the elements. So we'll go down here. This is a good frame to do it. We can see that got everything layered together. Let's take a look at just the reflection pass by itself. And it looks good, but it might be just a touch on the bright side for a ship of this kind. You'd think a military vessel would be a little bit more matte and a little bit less reflective. So we'll go ahead and add a color corrector to the reflection pass. And we'll do the color correction before the displacements here. There's another note about combustion and After Effects as well. Although they're different because After Effects layers things in a top-down order, combustion layers things from a bottom-up. So you're stacking the operators on top of each other and they get calculated in that order. So in this case, the discrete color corrector is going to go first, and then the displacement, and then the compound blur on top of that. And by changing the order of those things, you can sometimes make, extremely different changes. But in this case, we want the color corrector first, and then we'll blur on top of those. So in order to take them down, take the reflection pass down a little bit, what I'm actually going to affect is the gamma. The gamma is kind of the midpoint of the bright and dark, and it kind of determines where the midpoint lay. So if we look at the gamma of 1, if we turn the gamma up, everything starts to get brighter. And the top and bottom doesn't actually change much, it's just changing the midpoint there. So that's what we want to do. We want to just bring the gamma down just a touch. Doesn't have to be much. Then we might want to bring down just a little bit the highlights of the reflection a little bit. Just kind of play with it until you like it. Then we'll take a look at the whole comp together. And that looks a little bit better. It's still got the realistic reflections, nicely done, but it's not quite so shiny as you might expect. The same kind of thing with the specular pass. With the spec pass, and then here's without the spec pass. I think somewhere in the middle is where we really want to be. And we could just do something as simple as changing the opacity down on that. Take it down a little bit there, around 75%. And that starts to look more like what I expect. Now with all the reflection and background radiosity turned on, it actually is appearing pretty bright. And it's probably appearing a little too bright for the actual scenery that surrounds it. So what we want to do is we're going to go ahead and bring down the background radiosity just a touch. And that's the thing about this, it's very, very subtle, and you can spend weeks tweaking on something. So you just have to determine where it is that you want to leave things. I'm going to go and zoom in here a little bit and bring the background radiosity down. You can kind of get the impression from the pixels there. And just something like that, just a little bit less. The old adage is that 10% of the work takes 90% of the time. That's absolutely true in compositing. This is where it gets the final sweetening. This is right before it goes out the door, so you want to make sure that you get it exactly the way you want it. And compositing is what gives you that power. Now this is a perfectly fine image, and anybody would be proud to have made it. But there's a few more things that we can do to make it just a little bit sweeter. The first of all is making specular highlights. Now, we turned some of the speck down just because we didn't want it to be too shiny. But for the specular glints that you do get, sometimes you want to do a little something extra. And especially if you have heavily treated footage, a bleach bypass or something like that, that you get really bright highlights. And here's how you do it. We've already got our specular pass broken up here. What we're going to do is actually duplicate that, and then we're going to apply a color corrector to it. So a quick note about duplicating in combustion. When you duplicated an object such as this, the objects underneath it stay linked. That is, anything you do to any operators underneath them will be done to anything that you've duplicated that way. It's represented by italics so you don't get confused when it is and when it isn't. If you don't want something to be linked, you'll want to copy and paste, and that'll make another copy of things that are unlinked. So in this case, these things aren't going to change, and really if we did change them, we'd want that to be propagated through everything, so we'll just leave it alone. So we'll bring our color corrector here, and we're actually going to bring the opacity back up on the layer, and we're going to brighten it up significantly. And we're going to bring down the gamma a little bit, and what we're doing here is we're brightening the highlights, we're making the highlights wider, but we're bringing down all the mid-tones by turning the gamma down, making the mid-tones much less. So what we're getting is we're getting tighter, hotter hot spots. Now we'll go back to our overall comp, and you can see where those have been. Then it's a simple matter of adding a blur operator on top of that. Gaussian blur is my favorite. Box blur is faster, but it's not as high quality. And we'll just do a little bit of a blur. So now we've got blurred highlights. Now what I like to do is actually do this a couple of times, copy and paste that with different blur radii and different brightnesses. So we actually want to have a blur that's less and is brighter, and then a blur that's a much wider blur. But then we'll take the opacity down on this some. And again, this is just something you kind of feel out until you like it. That's the kind of thing that you might want to do. Not really, appropriate in this case, but that's a good way to do it. Now that we've gotten our ship in there, it's sitting in the scene very well. The lighting looks nice, the dust looks good, colors are all happy. We want to take it just that one next step, and believe it or not, that actually involves degrading some of the beautiful work that you've just done. It's strange, but matching the background footage by doing a little bit of blur, a little bit of grain, can actually take it from looking like really good CG to making people wonder where you got that footage. So what we're working with here today was shot on DV, so it doesn't have grain per se. We're going to use the Combustion's grain tools, and it's going to give us just a little bit of noise to get in there and kind of fool the eye. It won't be perfect, but it'll get us a lot of ways. And we're going to do a little bit of blur just to match the blur that was on the lens and in the footage. So what we want to do is we're going to have to go through and do a little bit of blur on each of the elements, a little bit of grain on each of the elements as it's appropriate. We'll go ahead and start with the background radiosity because it's kind of the foundation of the whole thing. And we've already got the compound blur from the distortion, but this is going to be separate, so we're going to add another blur on top of that. We'll do a Gaussian blur. And we'll just start off with, say, a half a pixel. Doesn't have to be much. You can see how it's affecting the edges there. Haven't seen how it's going to affect too much else because we've got the speck and diffuse layers over that. So we want to go ahead and add a blur to each of them. and we'll start off with a half a pixel there as well. These are all just starting off values, and we'll see how they work together. We'll go ahead and add the same blur. We can just copy and paste this blur up to the reflection pass. We won't bother with the shadow pass. It's already got a blur on there, and that's looking pretty good. And we'll go ahead and add a blur to the dust pass, actually. Might go ahead and turn that up to 1 just a little bit. See how that looks. So that's starting to, starting to live in the scene, really. Blurred out the speck, I think, maybe a little too much. Let's go back down to the speck here and see. Brighter things tend to be, higher contrast and therefore sharper. So we'll leave a little bit more of the speck in there and see how that goes. And these lines here are a little bit too sharp, so let's blur those up a little bit more. See how that goes. That's a little better. Let's take our background radiosity up just a touch as well. Let's take a look at it, and that's starting to look more like the footage around it. Now, let's see, maybe take that speck up just a, we'll take it up 0.5. And see, that's that's starting to sit in there. So now what we'll do is we'll add a little grain, and like I said, the grain isn't going to get us all the way. It's just going to get us hopefully enough to fool the eye of the viewer. So we'll go ahead and start with the background radiosity. You want to make sure to put the grain on the very top after you've done all your blurs. It's the last thing that goes. Combustion's got really good grain management tools. Everybody's got a noise or grain function of some sort. There are other plugins like Grain Surgeries you can buy for After Effects or Combustion, and they'll give you a little more advanced tools. They tend to be slower as well, but you take the good with the bad. We're going to use the match grain tool here, and what this is going to allow us to do is draw a box that Combustion will then analyze for the grain. And don't worry, even though I'm drawing it over the dust here, it's actually not looking at that. It's just looking at the layer that I have it applied to. And you can see over in the preview window here, it's given us a preview of what the grain will look like. Now, this is just a starting off point, so don't freak out if this doesn't look like what you're expecting. This is giving us a nice grain over it. It's a little high, it's a little heavy, so we're going to turn the gain of the grain down until we get something more like what we want to see. Now, we want to turn down the size a little bit because we're just kind of using this for a noise function. It's not really matching the grain, so it's more important that it looks right rather than it is right, since there really isn't any right or wrong. That, I think, is looking pretty good. It's just breaking it up a little bit, just making it noisy so that it doesn't look so crystal clear and crystal clean and computer generated. So we'll go ahead and copy that up to the dust pass. The dust sits in front of everything, so it's going to have a big effect on things. So I want to start that working, start at the top per se. Let's turn that up a little bit here. Let's see how it looks. Might make this grain just a touch bigger here. Might be a touch hot. Bring that down. And there, now that's broken things up just a little bit, broken up the body a little bit, broken up the dust, and now it's really starting to live in the scene. You can take a look through this area here, and I challenge you to show your friends and let them see if they can tell what's real in CG. Let's make a quick preview of the end here and see how well we've done. So now we've got the preview playing here, and we can see that our grain is working, our blur is working, sitting there in the scene very nicely. I think it's safe to call this one done. So let's take a look at our final render. Now you can see here that the ship's coming in, and we can see the heat distortions and ripples underneath here that we made with hypervoxels, and the dust comes on, and we've got all of our layers combined, got everything put back together from the elements that we broke up in Lightwave. And now you can see the power of compositing for tweakability. So that about sums it up for this program. Today we've learned how to do some hypervoxel dust. We learned about texture environment and background radiosity, and we learned about how to break up a Lightwave scene into all the elements and put them back together in compositing, where you can tweak until they really, really look real. We learned how to add some grain and add some blur to match the background. So happy compositing, keep tweaking until you get something that you like, and remember, there aren't always good answers, they're just the answers that work for you. And look for more programs from Desktop Images on visual effects and compositing in the future.